This is Unit 5, Day 7. Okay, complex numbers. So now we remember, we learned yesterday that complex means imaginary. Okay, so imaginary numbers. And it talks about that proper form is a plus bi. Okay, so the imaginary piece of it always comes second. Okay, so for example, if I did 4 plus 5i, your imaginary part goes second. So this is my a, and that is my b. Okay, so example 37, like real numbers, complex numbers may be added and subtracted. The key to these operations is that real components can combine with real components and imaginary with imaginary. So only something with an I can be combined with something with an I. So find each of the following sums and differences. So right here, if it has parentheses here and it's addition, it really means nothing. So I have negative 2 plus 6, which is 4. And then I have positive 7i plus 2i would be plus 9i. Okay, so if you wrote it as 9i plus 4, you're going to lose credit because it has to be an a plus bi form. Okay, part B. Now this makes you distribute the negative and change sign. So it's going to be negative 2 plus 7i. Now to combine these, I have 5 minus 2, which is going to be 3. And then I have positive 3i plus 7i, which is plus 10i. Next one, plus means nothing. So I have 8 plus 12 is 20. 4i, take away 1i, would be plus 3i. Okay? Alright, part D. Again, distribute the negative. So that becomes plus 8 minus 2i. So I have negative 3 plus 8, which would be 5. And then I have positive 5 minus 2 would be plus 3i. Example 38. Which of the following represents the sum of 6 plus 2i and negative 8 minus 5i? 6 take away 8 would be negative 2. Positive 2i minus 5i would be negative 3i. So it's negative 2 minus 3i, which is choice 2. Alright, graph the sum found in example 38. So make sure you guys are paying attention. They want us to graph that. Alright, so this is the real. This is like your A, and imaginary is your BI. Okay, so if you have A plus BI, this is like the X, this is like the Y. Okay, so when you're looking at negative 2 minus 3i, that's like saying this is the X, this is the Y. So negative 2, but then down 3, there is the point, negative 2 minus 3i. Okay, pretty easy. Think I, Y, it rhymes. Example 40. Use the graph below to answer the following questions, and it's telling us we are plotting all of those. Okay, so for A, it's positive 5 up 2. This is A. Okay. B is positive 3 down 2. So that's example B. C, negative 2, negative 4. Left 2, down 4. That is C. Now this one means there's like no X, there's no real number. So you're not going left or right, you're only going down to negative I, and that's D. Okay? E is positive a half, so that's right here. There's positive a half, but then up to 1. So that is part E. And then F would be 0, meaning you're not moving left, you're not moving right. You're at the origin, and right there, that is your F. Example 41. Multiplying two complex numbers is like multiplying two binomials, except one can use, okay, this is going to be huge, guys. You know this. I squared is negative 1 to further write the expression. So you can either FOIL or box this. Okay, so for A, I'll FOIL, but for B, I'll box. Okay, so my first terms, I get 21. My outer terms, I get plus 6i. My inner terms, I gotta switch, well, actually I'll just erase this. My inner terms are 5i times 7 would be plus 35i. Be careful with your last. The last is 5i times 2i. You're multiplying. So that's going to be 10i squared. But don't forget, I squared is really negative 1. So this whole thing right there changes to a negative 10. How? Because it's 10 times negative 1 is minus 10. So when I combine like terms, it's 21 minus 10, which is going to be 11. And then I have 6i plus 35i, which is going to be plus 41i. And again, guys, pay attention that everything's always left in a plus bi form. Okay? Part B. I'm going to box it. So this would be negative 2, positive 6i. This is 3, negative 2i. So when I line up the boxes through multiplication, 3 times negative 2 is negative 6. This one would be 6i times the 3 is going to be 18i. This box would be a negative 2i times a negative 2 would be a positive 4i. And then last, again, you have a negative 2 times a positive 6 would be negative 12, but then you have I squared. Okay? So be careful with that box. You have negative 6 plus 18i plus 4i minus 12i squared. And again, this I squared is negative 1, so when I multiply this times this, it actually just becomes a plus 12. So now when I combine like terms, that is going to give me a 6. Okay? And then 18i plus 4i is going to be plus 22i. Okay? Alright, for C I'm going to FOIL again. So, it says 4 plus I times negative 5 minus 3i. So I'm going to multiply my outers, my first. I get negative 20. My outers, I get negative 12i. My inners, minus 5i. And my last would be negative 3i squared. Okay, that whole thing is going to change to a plus 3. Because basically this is a negative 1, so it's just switching your signs. So I have 20, negative 20 plus 3 is going to be negative 17. Negative 12 minus 5i is going to be negative 17i. Okay. Example 42. Determine the result of the calculation below in simplest a plus bi form. Verify with your calculator. Alright, so I'm going to do a little distributing here. That's going to be 8i plus 12i squared. Okay, we'll change this in a minute. But you guys know that's going to be a negative 12 because it's 12 times negative 1. Alright, FOILing. So my first terms I get negative 15. My outers I get plus 5i. My inners I get minus 6i. And my last I'm going to get a 2i squared. Okay, that whole thing changes to a negative 2 because it's 2 times negative 1. So now look, I have negative 15 minus 2 minus 12. Okay, so negative 15 minus 2 is going to be negative 17. Negative 17 minus 12 is going to be negative 29. Okay, now I have a 5i minus 6i, that's negative 1i. Negative 1i plus 8i is plus 7i. Okay, and again, there's your A, there's your BI form. Example 43. Find the following product, show all your work, use your calculator to verify. So we're just doing FOIL again. So I'm going to get 9 minus 15i. And then my inners are going to be plus 15i. And my last is going to be minus 25i squared. This whole thing changes to a plus 25. These in the middle, look what happened. They cancel. So I'm just left with 9 plus 25, and that's going to be 34. Now, if you guys notice something, look at this. That's 3 plus 5i. That's 3 minus 5i. Those are your conjugates. Remember, conjugates mean change your middle sign only. If it's a conjugate, when we were doing irrationals before, it was first minus last. Because these are complex, or they're imaginary, the shortcut is to do a squared plus b squared. Okay, so look. This is my a, this is my b. Okay, it doesn't matter if you think that positive 6 or negative 6 is your b, because when you square it, it ends up being positive anyway. Okay, so if I have a squared plus my b squared, negative 2 squared plus negative 6 or positive 6 squared, it doesn't matter. It's going to end up being 4 plus 36, which is 40. If you doubt this and you don't like this way, FOIL the whole thing. These are conjugates, so your outers and your inners in your FOIL are going to cancel. Okay, so in this case, my A's are 4. My B's, you could think of them as 1 or negative 1. Again, it doesn't matter because you're squaring it, so it's going to become positive. So you get 4 squared plus, I'll pick 1 squared this time instead of negative 1 squared. Okay, but even 4 squared plus negative 1 squared, guys, is going to be the same thing. So you're going to get 16 plus 1, which is 17. There's my answer. Okay, example 44. What are each of the binomial pairs called in example 43? We already said that. They're called conjugates. What did you notice about their products? It ends up just being the first number squared plus the second number squared. Okay? Complex conjugates. So, okay. So basically, complex conjugates again. So complex means imaginary. Conjugates means their middle signs are different. So look at this. 4 plus I and 4 minus I. Here's your big formula. A squared plus B squared. Okay, I just did that for you. So now watch this. It says, which of the following products would be purely a real number? Now guys, it's only going to be a real number if they're conjugates. Okay? So you're going to look and see which ones. This one, different sign is in the front and a different sign in the middle. Those are not conjugates. So you're looking for which two are conjugates. Okay? Those have totally different numbers. But then look here. These are exactly the same. So there's my conjugates right there. Okay? Last one here, example 46. Which of the following is the expression equivalent to? Show how you arrived at your answer in your calculator. Okay, now, kind of like it's against the law to leave a square root in your denominator, you cannot leave an I, so we have to rationalize. How do we rationalize? You have to multiply the top and the bottom by the conjugate of the denominator. Okay, so let me show my work down here. I have 1 over 2 minus I. I have to multiply the top and the bottom by its conjugate, which would be 2 plus I. So remember, the shortcut on the bottom is just a squared plus b squared. Now it's a plus. So there's my a. 2 squared is 4. My b, you could think of it as 1 or negative 1. But 1 or negative 1 squared is also 1. So my denominator is just a 5. Okay, now the top, think about this. 1 times 2 plus I is just 2 plus I. So I get 2 plus I over 5. Choice 3.